Prove the theorem that states that the opposite angles of a cyclic quadrilateral are supplementary. Right, so let's see, how do you go about proving this circle theorem over here? Right, so in the exams you're going to be given a figure to work with, and your proof is going to be based on the labels on that specific figure. Right, for this video I am going to construct everything from scratch for myself. Right. Okay, so let's start off with a circle, obviously. Okay, so we have ourselves a circle. Okay, right, so let's see, from the given statement or from the theorem, we see that the important information is this statement over here that says that we have a cyclic quadrilateral. So which means that in my circle I have to construct some sort of a cyclic quadrilateral. Right. So I'm going to say given, right, circle, center O, right, with cyclic quadrilateral A, B, C, D, okay, with A on the major segment of chord, right, so with A on the major segment of chord BD, right, and C on the minor segment of chord BD. Okay, so let's draw everything that I'm saying I'm given, right? So I'm going to be given some center, right? So center O, right? And what I'm saying is I have some chord. Let's not refer to chord. Let's refer, because I'm not going to draw the line. Let's change this word chord to arc. Okay, so this is arc BD. Okay, so what I'm saying is that on the major segment, okay, of this arc, I have some point A, right, and on the minor segment, I have some point C. Okay, and connecting all of these points will create a cyclic quadrilateral ABCD. Okay. Okay, not the most beautiful cyclic quadrilateral that you've seen, but it will do. Right, so what are we required to prove then once we have this diagram? We're required to prove that angle A plus angle C is equals to 180 degrees. Right, so the opposite angles of the cyclic quadrilateral are supplementary. Right, so that's what we are required to prove. So let's think about the constructions that we're going to make in order to prove this. Okay, so constructions. Right, so we're going to have to construct some sort of radii. Right, so maybe the easiest thing to do is to construct the radii OB and OD, because then we can connect the angle at the center with angle A and also the reflex angle with angle C. Right, so let's do that. Okay, so we're going to construct radii OB, and OD. Okay, and then we're going to let angle BOD to equal angle O1 and reflex angle, the same angle BOD, but now it's the reflex angle that's going to equal angle O2. Okay, so let's put that in. Alright, so now we know that from the theorem that states that the angle at the center is twice the angle at the circumference, then this angle O1, okay, is going to be twice angle A, right? We can actually make that a little bit clearer with lines, so twice. So let's do this. So this angle over here is twice this angle, and I'm going to draw two strokes just to remind us that that is 2 times. And this reflex angle, right, angle O2, that is twice, sorry, angle C. Okay, just notice something else. These two, right, are on the same side or are subtended by the arc, the major arc BD, right, and the angle A's are subtended by the minor arc BD. Right, that's just one way to remember all of this connection, right? You can see this arc looks like this, and angle O1 looks like that, and angle A also looks like that, and the major arc looks like that, and angle O2 looks like that, and angle C2 also looks like that. It's just one thing I'm pointing out. If you are struggling to see the connection between the angle at the center and the angle at the circumference, especially if you can't identify this relationship here with the reflex angle. Okay, right, again, I am going to add strokes like that, right, and over here at C, I'm going to put 2 lines like that just to remind us that that is 2 times angle O2. Okay, so now you can see that the proof is actually coming out of the picture itself. Okay, so we are now ready to write down our proof. That's one statement, that's another statement, right? A third statement that we can make is that angle O1 plus angle O3, wow, where do I get 3? Angle O1 plus angle O2 is equals to 360 degrees, and that is angles around a point. Right, so we have some other representation for angle O1 and some other representation for angle O2, so why not substitute them into what we have right now? Okay, so therefore, okay, so angle O1 is 2A plus angle O2 is twice angle C. This must equal 360 degrees. Pull out a common factor of 2 equals to 360. Divide both sides by 2. Angle A plus angle C will equal 180 degrees. And there you go. That is your proof.